FGC, you also can get the primitive cell volume BC equal to 1 over 4A power of 3. Okay, the primitive essence for the body center cubic is this one. For face center cubic is this one. Okay, so now how do we find the primitive cell volume of FGC? It's also very easy. So you want to get this point, this point. So what at this point? If you consider this as an S, this as a Y, so this position is half A S plus Y. Correct or not? And then this one is Z, right? So this position is half A S plus Z. Then the other one is half A Y plus Z. So you get A1, A2, and A3. So after you get, see that? So this is a A1, A2, A3. Okay. So once you get A1, A2, A3, then you just use a very simple calculation to solve the volume. Then you solve it, you get BC equal to 1 over 4A power of 3. So 1 over 4 times A power of 3. Okay, simple, right? Then how many lattice points per unit volume? The unit volume is A3, A3, and A3. The unit volume for the simple cubic, not for the primitive. Okay, we have two volumes. One volume is for the cell, the whole cell. The other volume is only for the primitive. For primitive, it's only contained of one lattice point. But then for the whole conventional cell, for simple cubic, one. But body center, you have two. Face center, we have 4. Okay, but volume for the primitive cell for all simple cubic, body center cubic, and face center cubic, all only have one lattice point. One lattice point. Then now we want to know how many lattice points per unit volume. For simple cubic, you know there's one lattice point, and then unit volume is A power 3, so 1 over A power 3. For body center cubic, 2 over A power 3. Face center cubic, 4 lattice point, right? And then the volume is A power 3. This is the simplest way lah. Okay. Then next, you want to know what is the number of nearest neighbor for simple cubic, for body center cubic, and then for face center cubic. So this is the case for the simple cubic lah. So the nearest neighbor, let's say I take this as a center atom. The nearest neighbor, you have 1, 2, 3, 4, 5, 6. Okay, 6 nearest neighbor. What is the distance? Here to here is A. Here to here is also A. Here to here is also A. All are A. Okay, the nearest neighbor. How about the second nearest neighbor? For simple cubic, nearest neighbor is 6, and then the nearest neighbor distance is 8. How about the second nearest neighbor? So again, I take this as a center atom. Second nearest neighbor will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you see that? 9 to center atom. So 1A, A. Hypotenuse of A. 9 to here, same. A. 11, A. 12, A. See that? How about 5? So here to here is A, here to here is A, so hypotenuse. How about 8? Here to here is A, here to here is A, then here to here is hypotenuse. So they have the same distance. So what is the distance between the second nearest neighbor? Let's say for this atom and this atom, just now I mentioned that. So this is A, so this is A. So this is A squared plus A squared square of A. So this is the nearest neighbor, second nearest neighbor distance. So we have square of 2A, okay? So we have square of 2A squared, square of 2A. So how about this atom to this atom? Same, right? This is A, this is A. So this is square of 2A. So there are 12 atoms that having the distance of square of 2A. Okay, how about body centered? For body centered, what is the number of nearest neighbor? This is the body centered. Okay, body centered. If I take this as a origin, can you identify which is the nearest neighbor? Pink color one, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, nearest neighbor. If I pick the corner atom as a center, I pick the corner atom at the center. So there are 1, 2, 3, 4, 5, 6, 7, 8. If I want to pick the corner one, I want to pick the center one. So this is at the center one, right? Center one. So the nearest neighbor also 1, 2, 3, 4, 5, 6, 7, 8. Exactly the same. Okay, so for the nearest neighbor is 8. And then how about the nearest neighbor distance? Nearest neighbor distance. How to find the nearest neighbor distance? It's very difficult for me to draw here. I'm not sure I put that. Okay. You need to get the, okay, let's say I want to get, it's very small. I want to get the distance between this point and this point. Right. So how to get it? This is half A. And then I want to calculate what is the distance between this point to this point. Okay, this is actually half A, half A. So this is half A, this is half A. So this is hypotenuse of half A. So hypotenuse of half A square plus half A square, then square root of it, then you will get the answer. You get what I mean?